Hello everyone, welcome to Fresh Concrete. This is one of a series of events produced and recorded as a collaboration between the Concrete Centre and the Building Centre. My name is Elaine Toogood. I'm Director of Architecture and Sustainable Design at the Concrete Centre, and I am going to be introducing today's speaker. So just in case you're not aware, this series has been created to share just some of the wide-ranging innovative practices and new types of concrete emerging to address climate change. So these are technologies that bring a fresh approach and fresh thinking to the way that we make and use concrete. Now, this Fresh Concrete recording features innovation in the process of manufacturing. And it's one of two that we have put together. And for this, we are delighted to be joined by Mcdermott. He's co-founder of Nationwide Engineering. He's going to be presenting their work using graphene-enhanced concrete. Now, the trials of these have indicated the creation of stronger, more durable concrete, and with that brings opportunities to reduce the need for reinforcement and therefore also carbon savings. Now, before I hand over to him, I just wanted to give a little bit of context to that. There are so very many examples of innovative concrete manufacturing that we could have chosen. Concrete, as I'm sure you all know, it's already capable of being manufactured and used in a myriad of different ways, depending on its location, its scale, the ingredients that you're using, the credentials that you need it to meet. And there's a huge amount of innovation happening within this field. Principally, most of it, I would say, driven by the need to reduce carbon emissions, certainly in recent years anyway. So although the industry itself has been decarbonising for a while, I will talk about that in a second. So most of the other talks in this series could also have fallen within this category. And the reason for that is because the manufacture of concrete isn't just about using different constituent materials or how they're produced or made, it's also how they're put together in the mix and also how and where the concrete is placed and formed. So the concrete and cement industry decarbonisation roadmaps provide quite a good context and summary for areas of technological development and innovative manufacture that are happening now, but also how they setting out how they potentially can be developed and scaled up in relation to concrete and cement manufacture. The one on the screen at the moment is the Global Cement and Concrete Association Roadmap, and it identifies numerous areas of technological development and also behavioural change in order to be able to reach net zero. Now, not all of these are within manufacturing. Some of the identified levers are within the way that we use concrete, so hence I've said behavioural change. But it's a useful way and place to look for some of the sort of groupings of different technological advances of manufacturing for concrete. And of course, there's also the UK roadmap, which itself also has identified 7 levers. There are some separate lever papers with signposts for further information on some of those individual technology levers. So that's a good place to have a look for some further information. But of course, this is just a snapshot of the potential of concrete and how it can be evolving and changing its manufacturing. So some of those high-level technologies, if you like, include fuel switching. So this is reducing the carbon emissions by within the manufacturing of cement by switching to net zero fuel supplies, including a whole host of different waste-derived fuels. And with that come all the associated benefits of the co-processing benefits within the cement technology. There's also carbon capture, use and storage. For example, there's the cement plant in Morocco, which is using the captured CO2 from the cement plant there to grow microalgae for fish food. And there's many other capturing technologies in development being looked at globally and being already developed to scale up. It's a major area of technological development, as you might expect. There's also innovative industrial carbonation techniques. These were featured early on in the Fresh Concrete series. You can have a look at a recording of those. This is permanently embedding captured CO2 into the concrete during its manufacture, whether that's precast or cast in situ or within the aggregates that's used. And of course, there's also the manufacturing and use of lower carbon cements in concrete. And for that, that's including alternative raw materials, such as use of calcined clay, recycled brick dust, recycled cement, greater use of powdered limestone, and other materials like olivine or charcoal. There's a huge range of potential alternative materials and combinations to supplement those used today, as well as alternative activators as well. There's too many to mention, but there is a real change of approach in the manufacturing of concrete, driven by the need to decarbonize by looking at these different ways in which we can be making the binder that creates concrete. Now, some of these technologies may become transformative, and I suspect some of them will. Others relate to the facility and the means of being able to expand the usability and availability of existing low carbon solutions in concrete. And admixture technology in manufacturing, I think, has got a really key role to play in this regard, not only enhancing or changing the performance of concrete, but also including the potential to reduce the cement that's needed. And it is this category of manufacturing change and a manufacturing process that our speaker sits within today. Our next presentation is from Alex Mcdermott, as I said. He's co-founder of Nationwide Engineering, and he's going to be talking about graphene, but graphene being used to enhance admixture and how that is used within concrete. So over to you, Alex.
Okay, good afternoon, everybody. Yeah, my name's Alex Mcdermott. I'm the co-founder of Nationwide Engineering Group of construction companies, but more importantly and excitingly for today, co-founder of Concretene, which is a graphene-enhanced concrete. And I'm just going to take you through some slides just to give you an introduction and appreciation into the material, why we've come on the journey, and where we're heading on this journey as well. So, what is the big problem? I'm sure there's not a person on here who doesn't know the problem which we're trying to solve. And that, of course, is with concrete being the most widely used substance on earth behind water. It's also quite an intensive material in terms of resources. So CO2 output on a global scale, although there's various different facts and figures in the world, there seems to be a consensus around 8% of all global CO2 emissions are as a result of the production of concrete. But obviously it remains a critical material for the construction industry. It's not going anywhere. So what we need to do is to adapt the way we produce the material and the material itself to address this issue. And it's not an easy issue, hence why it's not been, it's been a material that's not changed significantly for many, many years. So the industry is being forced to address this by various different new inventions, new ideas, new ways of processing the material. And we believe that Concretene, graphene-enhanced concrete, will be one significant part of a range of new technologies that will be coming online over the next few years. So we've got to embrace this low carbon future. We see, as part of the construction business, clients demanding low CO2 technologies. There's no real way to achieve that, but the demand really is there. We feel the pressure within the construction business now to do something about it. So what have we done about it? So just over 3 years ago, we teamed up with the University of Manchester, specifically the Graphene Engineering Innovation Centre, and that was to work on graphene-enhanced concrete. It's been a journey of quite an extraordinary journey. And we've had ups and downs, plenty of downs, but in essence, we developed an admixture called Concretene. So it's a graphene-based admixture that you add into concrete. Really cutting-edge research and development. It's probably the first mass use of nanomaterial in the construction industry. So there's no sort of precedent of how to adopt such materials into the construction industry, as well as the very, very difficult science to get the thing to work in the first place. But we've made some great progress that I'll talk to you about shortly. And what we're seeing is that the graphene technology can significantly enhance the performance of concrete. And that reduces CO2, but also, depending on the application, potentially reduces cost as well. So, and there are other benefits that will be evident when I take you through the real world projects. It was just over a year ago, in May 2021, that we took the technology out of the lab for the first time and deployed it in a real world project. And that's just a couple of 100 meters from where I'm sat down here in Salisbury today. And since then, we've laid about 1,000 tons of enhanced concrete and many other projects in the pipeline. So just a little bit about what graphene is. I'm a civil engineer, I'm not a scientist, so I'm not going to go into detail about the science, but just as an overview, graphene is essentially just a single atomic layer of carbon or several layers of carbon. There's various different forms, platelets, oxides, functionalized graphenes, and I think we get mixed up really. Graphene is the buzzword of the moment, but in actual fact, it's a two-dimensional material. And in the family of two-dimensional materials, there's over 150 different types of this material. So it's bigger than just graphene as one single material. The theory for graphene has been known for many years, many decades, but it was first isolated and its properties measured back in 2004 at the University of Manchester by some clever people. And as a result, they won the Nobel Prize in 2010. Many facts and figures out. You've probably heard of many of these: 200 times greater than steel, a finished material at 1 atom thick, hence the reference to two-dimensional material, and also the largest surface area of any material. And we're taking advantage of some of these properties in Concretene. So what is Concretene then? So Concretene is a liquid-based additive that enables graphene solution to disperse uniformly throughout any cementitious material. So yes, we've focused on concrete, but you can also apply to screeds, mortars, etc., etc. And what we've done is we've developed this for mass use within the construction industry. And by that, I mean that it can be used in any concrete. So what we're not doing is specifying a certain mix design. We're not specifying a certain cement type or water cement ratio or whatever it may be. What we're saying is that as far as we believe, and you know, we've only come so far in 3 years, we've not tested it with all of the world's concretes, but certainly from the science that we've developed and the engineer we've tested to date, it can be used with any concrete in the world to enhance its properties. And it's through enhancing these properties that we're saving carbon. And the 3 ways we're saving carbon can be any of these 3 ways or a combination of them. Number 1 is reducing the quantity of concrete required. So for applications such as slabs, pavements, external highways, composite decks, etc., etc., what we're doing is taking advantage of the stronger material that's created by the use of Concretene to reduce the quantity of concrete required in the first place. Secondly, associated with similar applications, we're eliminating the reinforcement. And by reinforcement, I mean the traditional mesh reinforcement and also the joints as well. So those 2 generally go hand in hand with each other for these applications that I just referred to. What we're doing now is we're really focusing on the reduction in cement. So cement, depending on your mix design and where your constituents are from, can account for 70, 80, 90% of the CO2 associated with concrete. So for us, it's really important that we try to reduce the cement content to reduce the CO2. And that could be advantageous in a lot of structures where it might not be possible or desirable to reduce the thickness of the concrete section or even take some of the reinforcement out. So the reduction in cement is the current focus of where we're driving to at the moment. With the combination of those 3 on some of our reference projects, we've already reduced 50% CO2. Now that's in relation to our base concrete mix design, which is a 7-1 design. We're also reducing the reinforcements as I mentioned as well, but for the moment that is going to be really primarily focused on the mesh, as I say. So as we sit here today, we're not going to go out and build a bridge deck and take all the reinforcements out because we use Concretene. You know, it's still a concrete at the end of the day. It's not a miracle material. Cost I'll come on to a little bit later because it's easier to show you the practical examples. What's quite incredible and takes a little bit of head scratching is just how little graphene we're using. So in 10 tons of concrete, we're using less than 1 kilogram of graphene. In terms of the Concretene mix, yes, there's more volume in that, but in terms of pure graphene within the concretene it's less than 1 kilogram. So it's a very small quantity, and that's to do with what I referenced earlier, to do with a large surface area. And I think we've worked out that in a 20-ton, an 8.5 cube wagon, there's something like 5.5 million square meters of graphene within that. So this is where the material is very, very different than other materials that we know and use in our daily lives. And it's certainly a game changer, not just in construction, but throughout throughout industry within other materials as well. The concretene is improving the all-round strength, so it is the flexural, tensile, and the compressive strength. In addition to that, one of the key features is its rapid curing properties as well. So from initially casting and placing and finishing the concrete, within a couple of hours it starts to gain strength quite rapidly. And again, I can show you that in some of the practical examples. We're also seeing reduced porosity as well. Now, we haven't done any specific tests and measurements to define that. These are observations that we see in the lab. So part of the work this year is to understand just how improved that is, and that's all to do with the microstructure development within the concrete as a result of the concretene. We also see again enhanced durability. We're doing work with the fire resistance of the material as well. But again, they're early days, so we need to spend more time in the lab determining exactly what the material gives us. But all the sort of science and the testing to date is indicating a much more long life and durable product. And particularly if you think of applications such as ground bearing slabs, when we've eliminated the reinforcement and the joints in there, obviously they're the typical failure mechanisms, and also because it's less porous, there's less water ingress as well. So everything's pointing to a much more durable material. But again, we've got to determine that through testing, which we're doing later this year. What was really important to us, coming from a principal contractor background, so I'm a chartered civil engineer. I spent my 20 years in construction on sites. What was really important is making sure that whatever we developed was applicable to the industry and it didn't significantly disrupt it, because we knew that even if you had a good product, if it changed the way you had to traditional methods and the way to lay and deploy the material, then it could well be a non-starter. So we developed Concretene to fit in with existing technologies and be non-disruptive. And by that, I mean that the materials used in the batching plant, it's placed next to the plasticizer, it's pumped and dosed into the concrete wagon using existing hardware and software. Once it arrives on site, it just looks and behaves like concrete. It's laid with traditional techniques, and very few people can tell any difference between the concretene enhanced mix and a standard mix design. So we say it's really boring, it's just concrete, which is brilliant for us. That's exactly what we've been aiming for 3 years. So no specialist training either. The all-important question of accreditation, it always comes up, and it's a really interesting conversation, because we thought that we'd have a mountain to climb in terms of getting accreditation. But we're spending quite a lot of time looking at that at the moment. We think for certain applications that we can already use the concretene mix, it doesn't necessarily contradict the standards. And by that, I mean, if we focus on reducing the cement content rather than taking reinforcement out or reducing section sizes, then within certain parameters and depending on exposure classification and other particular items, then we believe it can currently be used with the current sort of standards. But it is an ongoing study as to where we take this in terms of accreditation. So just to show you a few reference projects, this is the one that I mentioned earlier. This is the first one that we did back in May down in Wiltshire. And this was as far as we know, the world's first graphene-enhanced concrete slab that was engineered and designed. So it wasn't a case of throwing some graphene in the back of a concrete wagon and hoping for the best. What we did is we took the learning from 3 years in the lab and we engineered back to first principles. So we designed the slab to standards, as we would do normally. And then what we did is we put that aside and redesigned it using the structure models which we've developed over 3 years from the lab work. And really going back to first principles, And I suppose when I say first principles, I'm talking more physics than engineering. So understanding what the material's doing at nano level and a bit more macro than that, but the physics of how the material's behaving and what the concretene and the graphene is doing to that. So we thinned this slab down. It was a 800 square meter slab with a power floating finish, and we reduced the thickness of this particular slab from 225 millimeters to 150 millimeters. Eliminated all the mesh reinforcement and the joints. There aren't any joints anywhere on this slab. And also, we'd normally use a thickening, a local thickening for where the double-story blockwork walls are sat on this slab. But we calculated we didn't need that, so it's just purely 150 mil unreinforced slab over the whole area with blockwork built on top of that. I mentioned earlier about cost, so this is a prime example. This is about £100,000 worth of work. Even with the cost of the addition of the concretene, because there was less excavation, less concrete, no reinforcement, we also saved time to do associated with the joints as well. But because the material cures quicker, the follow-on trays can get on quicker as well. So literally within a few hours of casting this slab, we were building the double-story blockwork walls off it in the middle of the slab. So we saved 2 weeks on the program as a result. And on this particular project, we saved about £22,000 on the £100,000 worth of work. So it was cheaper. But of course, the all-important figure here is the CO2 saving. So again, it's against our base 7.1 mix. We saved just under 14 tonnes of CO2 on this project. Another application, this is in the city centre of Manchester, right outside the Graphene Engineering Innovation Centre. A different application this time, so this one is designed for full highway loading. Same principle where we reduced the thickness and eliminated the reinforcement. So exactly the same principles, but designed for much heavier loading criteria. Our partner on this one was Cemex, and to give you an idea, we had a control mix, so a normal mix without the concretene addition. After 24 hours, that had achieved a compressive strength of 13.4 newtons. The concretene mix was at 27.7. By day 4, the control mix started to gain strength quicker, and there was a 50% margin or thereabouts. And depending on your mix design, your application, we generally seen a 30 to 50% strength increase, then maintained thereafter. Final project just to mention to you is Mayfield Depot, again another one in Manchester. It's the old goods railway station next to Piccadilly Station. Different application that's perhaps not obvious from the photos, but this is a composite deck up off the some 3 meters or so off the ground, which is basically an event space we were creating. 54 meters long, 14.5 meters wide. Similar principle with this one, eliminated the reinforcement and the joints. There are no joints. We couldn't thin this one down any further because the depth of the concrete from the top of the rib is only 73 millimeters anyway. But this was a great opportunity to develop take the technology off the floor, if you like, off the ground, and put it in a different type of application as we try and develop the material for use in higher rise developments. This one, we calculated a saving of just under 4.5 tonnes of CO2 on this particular application. So that was a quick snapshot of Concretene. I hope that was helpful, and invite any questions.
Thank you very much, Alex. That was excellent. And yes, we have got a lot of questions here. I'm not sure we're going to get a chance to run through them all, but I'll start. And maybe you'll be able to answer a few of them typing in afterwards as well. So first one, quick off the bat, was is there a joined up approach to the use of additives? There's lots of individual efforts to replace cement, but who's collecting the data and cross-checking for shed with regards to possible alternatives? And is there any difference with regards to geographical requirements? So it's all about, I'm guessing, being able to sort of the deployment of this within standard, I'm assuming, or is it more about data?
Yeah, I mean, it's a good question. We've sort of developed this really in isolation from sort of other products and other technologies. However, we are not particularly with additives, but we are associated with other potential, other technology that's coming on the market, whether it's carbon capture or whether it's more efficient design through using software. And many of these applications are going to be, the future of concrete will incorporate many of these applications. I'm not sure which ones yet. We're certain that Concretene is going to be a key component within that. But I think it's a really good point, because I'm not so sure, or maybe my ignorance, I don't know of any, I'm not sure that any of this is being sort of shared other than through conversations such as this, and the MPA and various different other bodies, whether this information is shared and potential synergies between the technologies as well.
Yeah.
It's a really good point, really. It probably wants looking at more.
I think it is. It's a very good point, and we'll put that into the mix of all the different things that we're looking at with regards to concrete technology. Yeah. So the ubiquitous question, which we're always asked on these, is that people are eager to use, is the costs involved and how readily available.
So all Concretene in the world is made at the University of Manchester in our labs. There are plans, highly developed plans, to scale that up internationally. The material itself, as in graphene material, is there's certainly no shortage of that. There's a shortage of demand at the moment, so the industry is ready to go. So none of that's an issue. In terms of cost, again, very good question. So at the moment, it's expensive because it is made in small scale in an expensive lab with very expensive people with white coats on, and that's around about £50 per cubic metre at the moment. We are in a position within 24 months to reduce it as we go out to the larger manufacturers, and we're envisaging a £10 to £15 per cubic metre uplift for the cost of the additive as a guide.
Okay, excellent, thank you. Now there's so many questions here that we're not going to go through. I'm just going to pick a few. There was one which I think is really important, is that that they were questioning. They said, you mentioned getting rid of joints. Did I miss something? Surely it still shrinks and you need joints. I think. Right.
Sorry, I forgot, really importantly, for some reason it doesn't shrink, our material doesn't shrink. Now we haven't done that. Again, it's another one we're doing the measurements for at the moment. We don't understand the fundamental science why it doesn't shrink, but at the moment we observe it doesn't shrink. So that is, again, we can't do everything at once. We've done some great work, but we need to take individual steps, sort of observing what we observe, and then go and find out why. And because it's a nano material, we're literally looking under the electron microscope down to atom level. All that takes time to sort of develop the samples and understand that. So yes, we need to understand the fundamentals behind that.
Yeah, absolutely, because it is one of the fundamental benefits that you're showing so far, with that cost question, because the time and cost associated with that post-finishing works is obviously what you would weigh up in the balance, isn't it?
Yeah, and we've done some quite large slabs, as I mentioned, 54 metre long, 14.5 metres wide. What we don't know is how far we can go without, is it infinite, is it 100 metres, is it 55 metres? I suppose that depends on your application, your thickness, and your other parameters as well.
Excellent. So there's a question here about use of it within GGBS. So I think with GGBS cement replacements, I think you've been trialing some of that as well. Is that right?
We have. We've done some early trials with GGBS, and we've done some early trials with silica fume. We've done some other trials with various different water reducing agents. Starting with GGBS, we've got some good results, but we probably haven't got enough to give us the confidence to give you any results, if that makes sense. So what we're looking to do, again, something we're looking to work with partners on, is to trial it with GGBS and silica fume and different types of super plasticizers, whatever it may be, because we need to understand how it behaves with all these different additives and cements. So that's one for the future again.
And does it change the colour of concrete?
No. Some people say it makes a slight difference, but they must have better eyes than I have.
I didn't notice any difference in the samples that you sent over to me.
No.
It's so small, such a small amount, isn't it? Yeah. Yeah. And so it's an interesting question here. It's about the dosage is so low and small, and the increase in the concrete properties. How can you distinguish that between the rest of the additive and the graphene?
I'm not sure I follow the question, sorry.
Well, I guess the question is how do you, within the additive itself, how do you know that it's the graphene that is bringing all the benefits?
Okay, that's part of our secret sauce. There is a way we're sure of that, but I dare not say anything because I'll get in trouble.
There you go. It was a tricky
But
question.
we are 100% certain it is that. The trick, of course, is to make sure that because you use such low quantities of graphene, low loadings, it uniformly mixed throughout the concrete, and that is a big challenge. But that is what Concretene does. Enables the uniform distribution of the material throughout the concrete. And
that's the key to it being in the admixture. So that admixture, is that added within would that be added in the concrete plant, or is that added into the truck? At what point does that get?
So depending on how different batching plants work, it's normally added in. It's normally mixed actually in the truck. So it's dosed in normally at the same time as the other additives into the wagon. So certainly before the wagon leaves the plant, it's dosed in. We're not designing this for the amateur market. It's designed really for use in concrete plants.
Absolutely. Absolutely brilliant. Well, listen, I'm afraid I think we're going to have to wrap up there because we're running out of time for this. But anybody whose questions aren't answered, we will share Alex's email address, and you can answer questions directly there. But he may also be able to answer the questions in the box now, answering live while the presentation is going on. So thank you very much, Alex. And if you could stop sharing your screen, and I shall share mine and switch your video off, that would be great.
Yep.
So thank you for all of those questions. And thanks again to Alex for an excellent talk. Please do look out for the other recordings in this Fresh Concrete series. They're available on the Building Centre website and the Concrete Centre websites and YouTube platforms, as well as, of course, the whole host of other case studies, innovation and guidance that we provide to help you get the best out of concrete. Thank you very much.